These are several of the terms that we're going to discuss. Most of this we will do in class. I wanted to go over the difference between relations and functions and the different representations that you're going to see. To do that, we'll talk about independent and dependent variables, also vertical line test. And independent is the x values. Dependent variables are your y values. Out of your book, there's this problem that word problem. You've got this athletics, introducing the sneaker. Here's a table of, you've got a week and how many pairs of sneakers are sold by week. So over 6-week period, different number of pairs of shoes that are sold each week. Looking at that data, does the sales represent a function? Now, all relations are functions, so we will be talking about different relations as far as the first section of chapter 2. Relations as in lines or quadratic relations or square root relations. So we will look at different types of graphs to start you out. And which ones of those are functions? This is a very specialized definition. And so we will look at what makes a function. So we've got maps, you've got a graph, you've got ordered pairs, you've got the table, which you already saw, a different kind of table, which was just the raw data. So we can rewrite that table again. The x values, which we said were independent variables, we can line up here. That is also called the domain. Your y values, or your dependent variables, we can put over here to the right of your domain as your range. And as they are paired up in your table, 1 and 8, 2 and 10, 3 and 15, 4 and 22, and so on, we can pair them up precisely. Usually they're not all lined up perfectly. You'll see them in your book with arrows kind of crisscrossing each other all different ways, and we will be talking about some other terms to one-to-one, onto functions or relations. And then here's your list of ordered pairs, and then here's the graph representation. The scale on my graph, my x values are in 1s and my y values are in 5, so I can go up by 5, and I did that here so that I could actually fit everything on here. So this is my 0.1 and 8. So if I go up 5 and a little bit more, nearly to my 10, that is my 1/8. This is my 2 and 10, up 5, 10, that's my point. And so those are all of my points. Okay, so we wanted to know, does this represent a function? This is a relation. Any set of ordered pairs together is a relation. So this does describe a relation. Is it a function? Yes, this is a function. How do we know that? There are several different ways that this is a function. One way we know is all of my x values are different. You can see that on the table. We also can tell that this passes the vertical line test. So if I could take a vertical line, here's how that vertical line test works. If I take a vertical line and pass it through my relation, it should only cross through one point at a time on my relation. So there's 1 point that my vertical line passes through. There's 1 point. There's 1 point, 1 point, 1 point, 1 point. If it passes through one and only 1 point anywhere along the relation, then it's a function and it passes that vertical line test. If it were to pass through a point here and maybe some other point along the relation on that vertical line test, then it would not be a function. So this passes the vertical line test. If you look at your list of ordered pairs, you can also see that all the x values are different, as we could also see in the table. You can look at the map and see that every x pairs with one single y. If we had 1 and an arrow going to another y, we would see that an x pairs with 2 different y's, and that would show us that it is not a function. Something else that we're going to do as well, and then we will talk about other things in class for 2.1. If we're given a function, and this is our function notation, It's called g of x. So this is just a name, and here is our expression basically. Stuff we did in chapter 1, you're just going to evaluate. We just have this new specialized notation. I'm going to evaluate 0.5 times x squared minus 5 times x plus 3.5. If I just covered this up, I could have given you directions and said, evaluate this expression if x equals 2.8. But now I'm going to give you function notation. So I'm going to evaluate at 2.8, and the next time I'm going to evaluate at 4a. And here's how that looks. Using my function notation, I'll do g of 2.8, and I'm just going to replace all my x values with 2.8. We're using the substitution property, if you saw that on the last slide. So plug in all of the 2.8. I'm going step by step. You can take your calculator and plug or substitute in the 2.8, and what we get is negative 6.58. So g of 2.8 equals negative 6.58. Do I want you to write this down? Yes. This is new function notation. You are now big people in high school in Algebra 2. You are expected to write the function notation correctly. So g of x is this function, and g of 2.8 is this value, negative 6.58. If you don't write it, yes, I'm going to mark it wrong. So just note it correctly, okay? We're going to evaluate this now at 4a. Am I going to get an exact value out? I'm going to get a new looking expression, so substitute in your 4a, and we will evaluate as much as possible. Note that you are squaring 4a. This will be 4a times 4a, and then you're going to multiply by your 0.5. So this will be 16a squared, and then times 0.5 times a half. That gives you your 8a squared, and then 20a plus 3.5. And this is g of 4a. This is as far as you can go. Remember, not like terms. This is an a squared. This is an a. And that is it for telling if a relation is a function, the different representations of relations, and how to find out if they are functions. And this is function notation and evaluating at a given value for that function.